Hello students, today we are going to solve second numerical of Buckingham pi theorem. Question is written as the pressure difference delta P in a pipe of diameter d and length L due to turbulent flow depends on the velocity v, viscosity mu, density rho and roughness k. Using Buckingham pi theorem, obtain an expression for delta P. Now we know that delta P is a function of diameter d, length L, velocity v, viscosity mu, density rho and roughness k. So we can write it as F1 is a function of delta P d L v mu rho k equals to 0. Now we have n equals to 7 here and m equals to 3. So n minus m will be equals to 7 minus 3, which will be equals to 4 here. Now the previous equation can be grouped in 4 pi terms as function of pi 1, pi 2, pi 3 and pi 4 equals to 0. Now each pi term contains m plus 1, that is 3 plus 1 equals to 4 variables. Out of 4 variables there are repeating variables. Now we have to choose the repeating variables. So rho, v and d are the repeating variables. So we have 4 pi terms as pi 1 equals to d to the power a1, v to the power b1, rho to the power c1 and delta p. Similarly, pi 2 will be equals to d to the power a2, v to the power b2, rho to the power c2 and L. Similarly, pi 3 will be equals to d to the power a3, v to the power b3, rho to the power c3 and mu. Similarly, pi 4 will be equals to d to the power a4, v to the power b4, rho to the power c4 and k. Now we have to find the solution of all the 4 pi terms. So for first pi term, that is pi 1 term, pi 1 will be equals to d to the power a1, v to the power b1, rho to the power c1 and delta p. So on substituting the dimensions on both sides, it will becomes m0 l0 t0 equals to l to the power a1, lt minus 1 to the power b1, ml minus 3 to the power c1 and ml minus 1 t to the power minus 2. Now equating the powers of m, l and t, power of m will be equals to c1 plus 1 will be equals to 0. So the value of c1 will be equals to minus 1. Similarly, power of t, it will be equals to minus b1 minus 2 equals to 0. So the value of b1 will be equals to minus 2. Similarly, power of L, it will be equals to a1 plus b1 minus 3c1 minus 1 will be equals to 0. On putting all the values, we will have a1 equals to 0. Now, by putting all the values, that is a1, b1, c1 in pi 1 term, we will have pi 1 equals to d to the power 0, v to the power minus 2, rho to the power minus 1 into delta p. So, it will becomes delta p upon rho v square. That will be the solution for pi 1. Now we have to find the solution for pi 2 term. Now pi 2 will be equals to d to the power a2, v to the power b2, rho to the power c2 and L. Now substituting the dimensions on both sides, we will have m0 l0 t0 equals to l to the power a2, lt minus 1 to the power b2, ml minus 3 to the power c2 and L. Now we have to equate the powers of m, l and t on both sides. Now power of m will be equals to c2 equals to 0. So the value of c2 will be equals to 0. Now we have to find the power of t. Now power of t will be equals to minus b2 equals to 0. So b2 will be equals to 0. Similarly, on equating the power of L, we will have a2 minus b2 minus 3c2 plus 1 will be equals to 0. On putting all the values, we will have a2 equals to minus 1. Now substituting the values of a2, b2, c2 in pi2 terms, we will have pi2 equals to d to the power minus 1, v to the power 0, rho to the power 0 and L. So it will becomes L by d. That will be the solution for pi2. Now we have to find the pi3 term. Pi3 will be equals to d to the power a3, v to the power b3, rho to the power c3 and mu. Now substituting the dimensions on both sides, we will have m0, l0, t0 equals to l to the power a3, lt minus 1 to the power b3, ml minus 3 to the power c3 and ml minus 1 t to the power minus 1. Now equating the powers of m, l and t on both sides, we will have power of m will be equals to c3 plus 1 equals to 0. So the value of c3 will be equals to minus 1. Similarly, power of t will be equals to minus b3 minus 1 equals to 0. On solving this, we will have b3 equals to minus 1. Similarly, power of L will be equals to a3 plus b3 minus 3c3 minus 1 equals to 0. On putting all the values, we will have a3 equals to minus 1. Now substituting the values of a3, b3, c3 in pi3 term, we will have pi3 equals to d to the power minus 1, v to the power minus 1, rho to the power minus 1 into mu. So it will be equals to mu upon rho v d. That will be the solution of pi3. Now we have to find the solution of pi4 term. So pi4 will be equals to d to the power a4, v to the power b4, rho to the power c4 into k. Now putting the dimensions on both the sides, we will have m0, l0, t0 equals to l to the power a4, lt to the power minus 1 to the power b4, ml minus 3 to the power c4 and L, because the dimension of k is L. Now equating the powers of m, l, t on both the sides, we will have power of m, that is c4 equals to 0. So the value of c4 will be equals to 0. Similarly, power of t, that is minus b4 equals to 0. So b4 will be equals to 0. Similarly, power of L will be equals to a4 minus b4 minus 3c4 plus 1 will be equals to 0. On putting all the values, we will have a4 equals to minus 1. Now substituting the values of a4, b4, c4 in pi4, it will be equals to pi4 equals to d to the power minus 1, v to the power 0, rho to the power 0 into k. It will be equals to k by d. That is the solution of pi4 term. Now substituting the value of pi1, pi2, pi3 and pi4 in the parent equation, we will have f1 is a function of delta p upon rho v square. Similarly, L by d. Similarly, mu upon rho v d. Similarly, k upon d will be equals to 0. Now delta p upon rho v square will be equals to phi, which is a function of L by d, mu upon rho v d and k by d. That is the complete solution for this numerical. Thank you very much, students.